So, parallelograms.
You need to calm down now.
Topic 6, section 3 are parallelograms. We know what a parallelogram is. We know a lot about them already. Okay, so this shouldn't be hard. We're just got a lot of stuff to list. So, a parallelogram has two sets of parallel sides. What is one set?
BC and
BC
and AD.
is parallel to AD. Okay, what is another set?
AB is parallel to CD.
AB is parallel to CD. Okay. What is now if they're parallel, right? Any line that crosses them both is a transversal. Yes.
Yes.
So what would be the transversal up there?
BD.
BD. I can move that up a little so I can get all these. Okay, so now I do apologize. These should all be congruent. All of these ands should be congruent. I thought about that last night when I was doing it, and I obviously didn't do it this morning. I was going to fix it. So all of these should say congruent. Does that make sense? Okay, so it says parts that are congruent. So if I just said I have a BC is parallel to AD, and so I have a transversal here, I should know some things about some angles, right?
So A and C are parallel.
No, we're talking about congruent. Okay, we don't know A and C are congruent yet. We have to make these triangles congruent before we can get these angles to be congruent, correct? So
could it be BAD is congruent to BCD?
BAD, no, we can't get to this angle until we get other angles. We got to make the triangles congruent before those angles are congruent. So if this is a transversal, this line is parallel to this line. What do I know about this angle and that angle? Why are they congruent?
Opposite
They're
interior.
alternate interior angles, correct? So CBD, angle CBD is congruent to angle A, oops, I forgot my angle, ADB, right? Because they're alternate interior angles. Okay, well, what do I know about this angle and this angle? It's the same thing because they're alternate interior angles, correct? So that would be A angle A B B and angle what?
Sounds like you're saying angle ABB.
Oh, A B D and
ABB.
angle
BBC.
D B D C.
BBC.
Okay. What do we know? Oh, we know that B D is congruent to what?
No, no.
BD.
D-
CA.
no,
or
it was BD is
AC.
congruent to BD.
BD is congruent to BD because the reflective property, right? They share it. Okay,
Would AB and CD?
A, B, yep. So, well, not quite yet. We have to do one more thing before we can jump there. So, do we see two triangles? You guys see a triangle 1 and a triangle 2?
So is this what?
Okay.
So do we-
Can I
So-
see that? I need to see that, please.
So, I know that there is an angle and a side and an angle that are congruent. Do we have an angle, side, angle?
Why'd
So,
you
by
put B-
angle, side, angle,
Why'd you put BD twice? So,
Because they're congruent. The reflected.
Mrs. Nick?
I thought it would have been BB, wouldn't it? What? Hi? Hi.
If you're
Okay.
hearing this, it's too late.
Hard time to show you guys.
Okay. Okay. BD is BD because of the reflexive property.
That
Do
fell.
not.
No, that honestly fell. I swear.
Okay,
I
well,
swear.
somebody turned it.
I caught it.
Liar.
So, what do I know then? That these two triangles are what?
Congruent.
Congruent.
have a
So I know
question.
triangle
ABD.
A, B, D, right,
Yeah.
is congruent to triangle what?
CDD.
BCD.
B. C, D. What's your question, Juan?
Why is BD and BD twice there?
Because they're reflexive. It's the same line. So it's congruent. Okay, so now we've basically written a proof, guys. We've gone through and said we know this. Why did we know the first one? Because they were what? Alternate interior angles. And the next one was alternate interior angles. And the next one was the reflexive property. And the next one was angle, side, angle. So we've done that. So now that we've done that, now we can say the other things that you guys were trying to say that I said were true. Now we can say them. Does
So
that make
then-
sense? We had to show the triangles were congruent.
So the AB and CD and BC.
AB. Is congruent to what?
BC or CD.
CD. And then AD
BC.
is congruent. I forgot to change my current runs. To BC.
And.
Can I see those?
Now angle A and angle C are congruent. Why don't I have to name those with the three parts?
And then.
Wait,
Because
wait, wait.
they're at the corner.
Because they're at a corner with nothing else, right?
Yeah.
Now we're gonna name B and D. We're gonna name it the right way. We're gonna do three parts for B and D. Okay? So it's gonna be angle A, B, C is congruent to angle what?
Oh.
A, B, C. Now the reason I had to do this is because they were cut in two, right? Okay, so there's a lot of parts of this that are already congruent. Did you know that about most of that anyway? Yeah. Okay. So we can use all this information to help me do other things. Okay, so that was the hard part of the whole thing. Okay, what is YZ?
YZ.
Mhm. So what?
It's 3.17.
So it's 3.27. What's WZ?
5.09.
5.09. What do all the angles in this shape equal? 360 because there's four sides, yes? And every quadrilateral, if I would use the formula, what's the formula?
A180.
180 and minus 2. And this was the sum of the interior, right? Angles? Okay, that was from 6-1. So I have 180 and 4 minus 2 is 2. So I get,
Sun, interior,
Yeah,
it's a
sun.
put another hump on it. You know what it's supposed to say. Okay,
They might not.
what? I said it.
Yeah, but maybe they're
Obviously
not.
not, because he said
Bring
sun.
it down.
I didn't say sun.
Yeah, but I said what if
I
they're
know,
not
I was
listening?
talking to him. Okay, so there's things we know about this, we're going to use it. Next thing is consecutive angle theorem. If a quadrilateral is a parallelogram, there's a difference, right? Parallelograms have two sets of parallel sides. Okay, if it is a parallelogram, anything? Then, that should be then. No, the consecutive angles are what?
Congruent.
No.
Equal.
Parallel.
Okay, we're gonna go back to our transversal up here.
No.
Yep. Okay, this is our, this is our parallel lines, yes?
Credit.
And this is our transversal, yes?
Yes.
What do I know about same side interior angles?
They're
BBC.
add up to something.
They add up to what?
360. It's a
180.
180.
So
Okay, is this also a transversal?
Yeah.
So what would this angle
180.
and this angle equal?
180.
180. So what is that word when things equal 180?
supplementary.
Supplementary. Okay, so you get the whole thing on there. It doesn't make sense. I'm
First.
reading that. If a quadrilateral was a parallelogram, this should be then the, don't you think? Then the, okay. Then the consecutive angles are what? Supplementary. Okay. I can find mistakes. I think I typed it the way they did, but I don't like how it's written.
There's nothing wrong with that.
Okay, so they just say they're parallel, yes? And they have to be parallel for these transversals to happen, don't they? And so it says AB are supplementary, yes? And CD would be supplementary. BC, would they be supplementary? Yes. And what?
Yeah.
And AD. They would all be supplementary because I can make transversals where? Here, here, and here. Not that one. So I can make transversals any of those places.
Why can't you make this shape?
Here, this one? Well, that's the parallel line.
Oh, done.
Okay, next one. Bisect. What does bisect mean? Cut in half, equal parts, right? So it says the bisector theorem, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Now, if they bisect each other, let me spell right, because I can't evidently. Bisect each other. So what does that mean? So I can add a note to myself? What is bisect?
Completely in half.
Cut in half, right? And I'm going to put 2 equal parts, right? That further broke down half, didn't it? So I know they're 2 equal parts. So that tells me that XA or AX is congruent to what? AX, AZ. And AW is congruent to what? AY. So if I knew AY, could I find YW? Multiply by 2, right? If I knew XZ, could I find AX? Divided by 2. That's it. I think we've got all our rules, now we're just going to use them. Okay, so it's a quadrilateral, it's parallelogram. What is the value of x and all of the side lengths? Oh shoot, what do I know? What do I know?
And you have to combine all of them.
No, I'm talking about sides, not angles.
Combine like terms.
You know, QR is parallel to
7x minus 3 plus 2x plus 12. Add your like terms.
But why are you adding them?
Because they're
Because that's how we've done it.
What do we know about sides? Go back and look at your sides. You're talking about angles.
I would just back them.
QR. is
Okay,
parallel
look
to
at your rules about sides, guys. Your sides.
Oh, we have to find all the. We have to find what x is. Plug it back in.
Right. So what do you know about the sides of this thing?
There you go.
The
The
parallel.
QR are going to be the same from PS. Like
Okay, so QR equals PS.
Yeah.
I
So what would
literally
I
said
do with those?
those equal.
You set those equal.
that. I said QR is parallel to PS.
You know, you said parallel. They're not. They are parallel,
And
but
then
that's not going to help me.
equals-
Just a second. Parallel is not helping me. What is helping me? That the fact that they are what to each other? Congruent. Not that they're parallel. They're congruent, so they equal. So 7x minus 3 equals what?
2x plus 12.
2x plus 12. What else do I know?
That's the same as the
Wait,
4x.
that
4x
4x equals 5x
Equals
minus
5x minus 3. So I got to solve them, yes?
Yeah.
So here I'm going to subtract 2x and add 3. How about you? Is that what you would like to do?
Yeah.
We're solving for x. Put your foot down.
Yes.
Okay, so I get 5x equals what? 15, so x equals 3. Have we done this a lot this week? Yes. Okay, now when I solve this next one, x better equal what? 3. So,
But aren't the sides are all going to be the same?
no, x equals 3. That's not a side length.
I know.
But
Yeah.
the x, since they used one variable, x all has to be the same.
Oh, okay.
You see what I'm saying?
Yeah.
Okay, if they would use y, then it wouldn't be the same. Okay, so I'm going to subtract 4x and add 3. How about you guys?
No, I mean, it doesn't matter.
It doesn't matter, we're going to get the same answer, right?
What?
3 equals what?
1x.
1x. So x equals what?
That didn't make
3.
sense.
Should I put?
So now it wants all the side lengths, yes?
I'm confused. Why did you add the 3 to the 4x when you
You
already
think?
No, I
Nicole?
didn't add the
I think
3
I'm
to the 4x, I
confused
added the
more.
3 to that side.
Because she already subtracted the
Because
4x.
I subtract, because there's not another.
Oh,
I just wrote it there. I'm sorry.
I'm like,
I should have wrote it like over here. Does that help? Okay. So now what do I do with my x?
Put x back in all.
Put x back in. So 4 times 3 is what?
12.
12. So the other side better equal 12, but I'm going to check my work. So 5 times 3 minus 3.
Yeah, it does.
So 5 times 3 is 15, minus 3 is
12.
12. Okay, 7 times 3 minus 3,
18.
18. And 2 times 3 plus 12,
18.
18. So, what you guys were first trying to do was like what we did with angles, right? We were trying to add them all up. If I had angles, I would add them all up and set them equal to what? 360, because that's what the total is. But we got to remember what we're talking about, angles or sides, correct?
yes.
Okay, so guess what we're going to talk about now?
Angle.
Angles.
Oh my god.
Okay, so it's parallelogram.
Missed that.
So B equals B.
B equals D, doesn't it?
Yeah, and then you add this together.
Okay, so what do all of them equal?
360.
360. I think this problem is exactly what we did a couple times yesterday in homework, right?
Yeah.
We know that B and D are congruent,
I
yes?
didn't do that right on my homework.
Okay, so we'll get it, so you can go back and do it right. So we can learn. Okay, so we know B and D
Learn.
are equal, yes?
Yeah.
So we have 2 times 114, because we have,
Question. I have a question.
what? Not yet.
Okay. So if you just added both of those,
Yeah, you get the same as 2
get
times.
360 minus
the
whatever
two
that added,
from?
and then divide it by 2, because then that would be.
Right, but I'm just setting up the whole equation. But yes,
But you could do that.
yes. Okay, so I
Where
have,
are you getting the 2 from?
Because there's two.
because there's
variables of
2
114.
114s. Okay, now, we don't know A and we don't know C, but we do know they're congruent, yes?
Yeah.
How many X's do I have?
2.
2. So plus 2 X's, yes? This is the formula. We did this yesterday without a formula, but we can also make a formula out of it. Okay, either way, you should get the same answer. So, 2 times 114 would be 228. So I'm going to subtract 228, yes?
And then divide by 2.
So I get 2 and 5 is 3 and 1, right?
Yeah.
Equals 2x. Divide by 2. So x, 2 goes into 13 how many times? 6. Carry a 1. 6. So 66 degrees is equal to angle A, which is also equal to angle C. And then we already wrote B, right? So we don't have to set up the formula if you want to add the two together. Adding two numbers together and multiplying by 2 is exactly the same thing, correct? I'm going to keep trying to get you guys to up the sophistication of your math problems. Does that make sense what I'm saying? Instead of adding 6 and 6, we're going to say 2 times 6. We're going to be doing those because we want to make our problems look simpler. And when we have a bunch of addition, like if I had 3 114s and I had to add them, would I want to do 314 plus 314 plus 314? No, I'd want to do 3 times. Okay, so that's what I'm trying to get you guys to do. Okay, given this GHJK is a parallelogram, we need to find A and G and H and J and K. Okay, so what they give me are H and G. What relationship do H and G have together? They're same side,
Opposite.
yes.
So it equals 180.
It equals 180 because on your consecutive angles theorem, Those are same side interior, yes? So they equal 180. So what would I do with these two things? So A plus 5 plus 8A minus 5 equals 180. I combine like terms. And I won't use add because if they were negative, okay? So I have 1A and 8A, so I have, no,
9A.
9A.
Oh.
And then I have positive 5 and negative 5, so I have 0. That's always nice, right? And then I do what? Divide by 9, and 9 goes into 18,
It's 20.
2, and 0. So I have A, yes?
So you put A back in.
And I'm going to put A back in. But I know that angle H is congruent. The angles are congruent, right? I always mess it up. It's congruent to K, which is going to equal A plus 5. But what's A? 20. So 20 plus 5 is 25. Now, I could, 25 times 2 is 50, subtract it from 360, divided by 2, or I could just plug it back in, right?
Yeah.
So I know that angle J is congruent to what? Angle G, which was equal to what? 8A minus 5. So 8 times 20 is, here, I'll plug it in. You can see it. To help?
160.
160 minus 5,
155.
155. So I can tell you what all the angles are without saying angle J equals 155, angle G equals 155, right? I can just make a big old long statement, can't I? Last example, right? 2. Okay. They're going pretty quick, aren't they? Okay. So now we're with diagonals. What do we know about these diagonals? What did they cut them in half, right? They bisect? Okay, so it says RSTU. It says SU is 35. So that's the whole thing equals 35, yes? Okay, and then it says KT is 19. So this is 19. That means this is what? 19. Okay, so it wants SK.
So you take.
Wouldn't it technically all be the same?
No, because this is SU is the whole thing. It's 35.
Would be.
And
So
I
all you have
want
to do
how
is
much of it?
35 divided by 2.
You want half.
So, yeah,
I
it
want
would
half. So SK is going to equal SU divided by 2, yes?
Yeah.
I'm just writing it out in symbols. So what was SU?
35
35
divided by 2.
divided by 2.
17.5.
So 1. No, yep, 7.5. And I don't have any units, do I? Okay, so SK was 17.5. I just took what I had and divided it by 2, right?
Yep.
And I can divide odd numbers by 2. That's always going to end in a 0.5, isn't it? Okay. So now they gave me KT was 19, and it wants
Couldn't you just
RT.
19 times 2?
So it's going to be 2 times KT, yes?
Yeah.
So 2 times 19, or 19 plus 19, right? Which would be
38.
38. I think diagonals are fun. They're easy.
I think if
The way I was
has a
thinking to do
bisector,
it
it's
is so much like more work.
Oh, I don't
You were going to
know.
do more work to get the same answer,
Yeah.
right? So we need to try to use our rules that we have. Like, you guys know things about parallelograms. You've been dealing
No.
with not triangles, rectangles and squares for a long time,
No.
which are parallelograms, right?
Yeah.
So you know a lot about parallelograms, but we want to make these more direct and use the rules better, more efficiently. Okay, so we have a new parallelogram. I know PK is 4. I know HK is 2/3 of GJ. We say those together. What is GP?
Well, first off, you have to find HK, which is just, since PK is 4.
Okay, so PK is 4. It's right here is 4. And so HK is what? So HK equals 2 times 4. So it is 8. So now I substitute that in here, right? So I have 8 equals 2/3 GJ. So now I need to get this 2/3 to be a 1. So what do I multiply it by? The reciprocal on both sides, right?
Yeah.
So I do 3/2 and 3/2. So over here I get 1, 1, 1, 1. I just get GJ. Yes? Okay. Now this is 8 over 1, correct?
Yeah, so wouldn't it
So 2 goes into 4. How many times? 2 goes into 8.
Or
be
4. Just give away the answer.
you did.
And 3 times 4 is
Well,
12. So GJ is 12. Yes?
Question.
Yes.
Could you just multiply it across and then
Yes, you could. But now with 3 and 8, that's really easy to do. But if your numbers are huge, you guys want to start getting in the practice of always reducing before you multiply. Because your numbers will get so big and then your brain will shut off reducing.
And then you divide by 2.
Okay, now GP is going to be what of GJ?
2/3.
No,
1/2.
1/2.
Ah.
So I need half of
12?
GJ,
That is 12.
and 1/2 of 12 is 6. So GP is 6. Now, dividing by 2 and multiplying by 1/2 are exactly the same thing, aren't they?
Yeah.
And if you can get that in your head, it will save you some time later on. Okay, just give me 1 second. When I hit stop, it's gonna give me a different screen and then I will put it back, okay?
Hold on, I'm almost done.
Okay. So everyone needs to
You're
remain quiet for a second. Are you good? Everyone good?